Now we're going to consider bisecting arcs and chords. And this leads us to a couple of theorems, one of which is if a diameter or a radius of a circle is perpendicular to a chord, then it bisects the chord. If a diameter or a radius of a circle is perpendicular to a chord, then it bisects the chord. And then a second theorem along with that is that if we've got a perpendicular bisector of a chord, then it's either a diameter or a radius. All right, well, let's see what we have here. Use a radius perpendicular to a chord. In circle S, well, we know this is circle S. How do we know? I see that S is the midpoint of the circle, and we name it based upon that midpoint of the circle. Find PR. Well, if I look at segment SQ, I see that it's perpendicular to chord PR. And how do I know this? Because it forms a right angle at the point of intersection, which in this case is T. So it is this segment SQ is perpendicular to PR. I also know that it's a radius because it's extending from the center of the circle to an endpoint of the circle. Center of the circle being S and an endpoint on the circle Q. And so it is bisecting this chord PR. And we're asked to find PR. Well, if segment TR is 6, and we see that that's so, it's 6, then PR must be twice that amount because segment SQ, the radius, is bisecting PR, and if we know what half of that is, well, then we can just double that to find PR, and that means that PR must be 12. 12 units. What's geometry about? Geometry is about thinking.